Okay, so thank you so much for your patience. And first of all, thank you for finding some time for joining us today. And it's my big pleasure and honor to host our webinar and present to you today our new work from home solution, which is especially designed for remote access and maintenance purposes. So first of all, I will quickly start from introducing myself. So my name is Jacek Konratowicz, and I'm ORing's Technical Business Development Manager. I'm currently located in Poland, but I'm also responsible for both European and Americas markets. So my second office location is Irvine in California. So today we are going to focus on our work from home solution. So first of all, I would like to introduce you some slides, a quick presentation with brief information about our work from home idea, our platform overview, and I will mostly introduce you the new features in our cloud platform, which is MagiConnect and MagiCollect application. And after the presentation, we'll do a live configuration demo for both applications, including remote access and remote data collection. So let's get started with work from home idea. So we all know that the year 2020 is quite extraordinary. So due to COVID and the pandemic situation, all of us are affected, and not only us, but also the industry is affected as well. All the factories and offices are struggling right now. Most of them are closed, and the production is really slowed down. And people are starting to work from remote locations. That's why it's so crucial and so important nowadays to have a good solution, to have possibility to access your field site, your premises remotely from different locations like your home. This is especially to check the status of the production, check the status of the devices in the factory, for example, collect the data for analysis. So here comes ORing with a perfect solution which can help the users and factories to have cost-effective and very easy to install remote access solution. And our goal is to provide a solution which is very easy to understand without expertise knowledge needed for networking. The solution is based on VPN connection, so you can actually connect with any remote location to factory and field site. And the data collecting solution is based on MQTT protocol, so you can collect data from devices in the factory for real-time monitoring. And of course, there is a high cybersecurity involved in the solution to protect the data and privacy. So for the solution, we are going to standardize remote access and remote data collection. And we recently released two applications which are called MagiConnect and MagiCollect. And I will start from MagiConnect first, which is the remote access solution based on our cloud platform and VPN standard. And this provides the users a possibility to access the field site remotely for remote control and maintenance purposes. And MagiConnect includes three items. This is a Connect server with a portal and dashboard located in the cloud. ConnectClient, which is a VPN tool which has to be installed on a machine which wants to access remotely to the field site. And there is ORing ConnectGateway, which is a physical device which is installed in the field. Then we have MagiCollect application, and MagiCollect is especially designed to provide remote data collection features, also based on our cloud platform. And this one is using MQTT protocol to communicate with end IoT devices. MagiCollect includes also data logger, so you can store the data safely and securely in the cloud platform, in the cloud for analytics and machine learning purposes. And the last part of the solution is the hardware. So we have different IoT gateways which can support both MagiConnect and MagiCollect. And these gateways, depending on the solution, depending on the application, can be the best choice to install in harsh environment, as all of them support rugged design. So current challenges with existing solutions and their limitations is that they usually use proprietary protocols without following industry standards. So it's very hard to make the integration of the remote access and the end devices in the field. So there are also compatibility issues, and a very important thing is the cybersecurity issue. So ORing's goal is to solve all of these bottlenecks with existing solutions. So our advantage of remote access is following SSL VPN and MQTT Spark Plug B protocol as a standard. We can do both remote access and data collecting at the same time. And we have compatibility with all devices which supports these mandatory common protocols like VPN and MQTT. We are also focused to provide very high cybersecurity protection. And the architecture of the solution is that we can support both public and on-premise installation with a local server. Providing standard softbound device API means that we can integrate many different end devices with standard protocols. And providing standard northbound RESTful API, it means that we can support software developers for customized applications developed on their own. So let's focus now on the PaaS, so Platform as a Service from ORing. Just a quick information that our solution is, first of all, easy to use, so it provides very easy connectivity of devices to the platform. It's secured because this is the key feature of sending the data to the cloud now. So Cloud Platform provides secure communication between the IoT devices and cloud application. And of course, it must be flexible. So we provide the RESTful APIs for IoT application development. And for the architecture that is supported by our PaaS, first of all, in the middle, we have, in the blue fields, we have the features supported by the platform. So we have account management, so the administrator of the system can change the privilege, the access for the different users. There's, of course, thing management, so the users can manage all the devices connected to the cloud. Data management, which is the most powerful feature for data visualization and storage. Network management, rule engine, billing service, also additional features which helps to maintain the connectivity with end devices and maintain the cloud platform. Then on the left side, we have southbound API with different protocols, like, for example, MQTT, CoAP, and our OpenGateway firmware feature, which helps very easily to connect our gateways to the cloud platform with just a very simple configuration. And then on the right side, we have authorization with protocol OAuth 2.0 and northbound API with the RESTful API documentation, which helps to integrate different applications on the top of the cloud platform. And current applications developed by ORing are MagiConnect, MagiCollect, and MagiCity. So now I would like to move to the MagiConnect service first. So first of all, I would like to introduce the system architecture and why it is so fast and easy way to remotely manage your device. So you can see in the middle is our MagiConnect server, and it provides the MagiConnect dashboard for the administrator who can arrange and control which devices can communicate remotely. And then on the left side, technicians or programmers or other users of the system can use the ConnectClient VPN tool to connect through our server to remote location where is the gateway installed. So we have different Connect gateways. It doesn't matter what kind of communication technology is used. It can be regular Ethernet connection. It can be wireless Wi-Fi or cellular 3G, 4G connection. All can support VPN and provide the remote access to the field site, and end devices are using interfaces like Ethernet or serial for local communication. So the MagiConnect system is very flexible in deployment. It means it doesn't matter what end device is located there. It can be a machine, it can be PLC, it can be a sensor, it can be a smart meter. Thanks to the multiple interfaces in our local gateways, we can communicate with these end devices, pull the information from them to the cloud platform, as well as serve commands from the cloud platform, and the user which is managing them from remote machine with ConnectClient tool. The dashboard of MagiConnect located in the cloud is very user-friendly and very easy to understand. So each device is shown with its configured name and online status. And so to make the connection, it's just enough to select the device, click it, and you can access it within just a few seconds. There is also EMAP integrated in the system. So besides the device status, you can also check its location on a map. And the MagiConnect Connect client, the VPN tool, is very intuitive and lightweight Windows-based tool, which you can install on your machine, which needs to be connected remotely. And with this tool, it's just enough to copy the Connect client ID, log in with this ID to the cloud platform, and that's actually all related to the configuration, which we'll actually show you later. And because our gateway also supports serial connection, if you have proper drivers and proper tool installed on our Connect client machine, it means that we can also enable VCOM remote access applications, so virtual COM port to communicate with serial devices in the field. Now I'm moving to MagiCollect service. So this is the solution for remote data collection. So the idea is to provide very ease of use for unexperienced users to make the MQTT configuration with end devices like sensors, meters, and PLCs. So inside our cloud platform, there is a database which is storing the data, and MagiCollect is also an MQTT broker, so-called server. So in this case, having access to the dashboard is very easy to configure the gateway remotely from the cloud, send this configuration to the gateway, and start collecting the data from the field site. And this can be done by the administrator, but also by the technician, programmers, and other users of the system. So with conventional machine management in old obsolete solutions, there is always a local management. So all the factories have local servers installed, local SCADA systems, local PLCs, which are responsible for data management and data storage. But then Industry 4.0 applications and modern IIoT applications involve some gateways, which helps to collect the information locally from these local devices. With different protocols, for example, like Modbus TCP or Modbus RTU, and then using modern IoT technologies, like, for example, narrowband IoT or LTE-M, low power WAN technology, cellular based, to send the information with different cloud protocols like MQTT to cloud platform. In this case, our cloud platform can support cloud-based machine management with MagiCollect, but also dashboard, real-time data visualization, as well as historical data visualization. It all can be accessed from a smartphone application, which is very helpful to access your data anytime and anywhere. And besides the data, the system can be enhanced with some added value. So not only data monitoring, but we can make like a big centralized management and integration of different kinds of features in the system, like environment monitoring, energy management, access control system, surveillance system, and more. So MagiCollect is based on MQTT, as I already mentioned. This is the most common IoT protocol now used in industrial Internet of Things applications. So MQTT is machine-to-machine connectivity protocol, and I think its biggest advantage is that it's very lightweight and easy to use and provides very low bandwidth consumption. So it's very easy to understand because it's based on publish-subscribe rule. So it's using just connect, publish, subscribe, and disconnect methods to send and get the data between the end device, the client device, and MQTT broker, so the server located in the cloud. So as I also mentioned, MagiConnect portal and dashboard is providing very user-friendly, easy to understand interface, but yet still very powerful, which can show you real-time data and historical data, and which can help you to control end devices, which, for example, support digital output. So right now you can see how the interface looks like. There is a device list, channel list, and detailed device info, where you can access very specific data and current value of measured data in the field. And not only real data, but also the data logger can provide database purposes, so you can always access the historical data, check its change in time. Depending on the time period you want to select, there is a filtering mechanism. So you can always access the historical data and present the data by chart. And besides the software, we also have our ConnectGateway and OpenGateway, so physical devices which can be installed in the field, which supports all of these cloud features. So we can divide them in machine-to-machine gateways and IoT gateways. In case of M2M gateways, we have support for both MagiConnect and MagiCollect. And one of the most popular products right now is IMG 4312D+-D4G. And one new planned product is IR20D. This is a wired device without cellular modem, which will be very cost effective. And you have IoT gateways, so Oreo G3218 as well as Oreo dongle. Both of them support MagiCollect application for data collection. So to give you some more details about the devices, IMG-431D+-D4G is a compact size industrial gateway, and it can support 4G LTE communication with a cellular modem and support for dual SIM card slot for redundancy. We have two Ethernet ports, one serial port, and what is most important for industry filter, there is also digital input and digital output, which is a new feature in our gateway. For IoT gateways, the most common product is Oreo G3218. It's a low power WAN wireless technology gateway, so it can support LTE-M and narrowband IoT cellular connection. And it's very generic for all IoT solutions because we have two serial ports, we have 4 digital input outputs, so we can control and manage many different devices in a factory floor. Another IoT gateway which supports MagiCollect is Oreo G80-112D5 narrowband. Also low power WAN wireless technology with ultra low power consumption. It's a very tiny device, very compact size casing, also generic for all IoT solutions. We have in this case one serial port and one digital input output, and also one power input in a range from 5 to 24 V DC. And there is a comparison between our gateways. So MagiCollect OpenGateway feature is supported in 4 models currently. One which is still planned is the wired model IR20D. This one will support Ethernet 2 serial communication. And wireless products can support narrowband IoT, Cat-M1 or 4G LTE. Depending on the project specification, we can choose between different needs, different port density, and different communication standards. And to finalize and summarize our presentation, first of all, I would like to give you some ideas about the application, so how the products and solutions can be used. So first of all, remote access to the factory floor can give you annual maintenance purposes and can give you help with diagnostic and troubleshooting of the devices in the factory without being present in the factory. So you can access to your factory from different locations, as we'll present this later during the demo. Factory owners can also have remote monitoring and data collection features. So in this case, we can do both private or public cloud. In case, like you can see right now in the diagram, there is a local server OPS 2100, which is installed locally in premises. And this server provides all the features related to our cloud platform, as well as MagiConnect and MagiCollect. In this case, the programmer or system administrator can connect remotely to the server, and the server which is installed locally is responsible for data collection and communication with local gateways, which then serves devices and devices like HMIs, PLCs, or cameras. A factory owner can also have more than one factory. In this case, we can do cross-factory communication. So we can create like a hybrid solution which where the cloud platform is responsible for centralized management, and we can connect multiple areas, multiple regions with local servers to send all the data, all the information, status information to the cloud platform. And still inside the factories, there can be different zones with different gateways, and each of these zones can be managed separately. One of other application is power facility management or solar plant management, where you can, for example, install a gateway, which then can serve IP cameras, measure the current generated by solar panels, measure the temperature or vibration, and any other values you need to check. This gateway can collect all of this information and can upload this to the cloud platform, where you can access it remotely anytime, anywhere for real-time monitoring, visualization, and data analysis. Okay, so that was a brief introduction of our solution. So first of all, now I would like to show you how to configure our product. So first of all, I will start from MagiConnect. I'm sorry. So I will go to MagiConnect page. Here is the page where you can learn everything about the solution. You can download the user manual, check what devices are supported in this with this feature. And there is a launch button where you can open the member login page. I am already logged in, so I will use my existing credentials, which are stored in my web browser, to access the main dashboard. Here in the main dashboard, you have a possibility to manage the MagiConnect system, add your gateways, check their location. You can see the gateways which belongs to your account, but also there is a filtering mechanism. If you disable show your gateways only feature, you will see all the gateways which belongs to another users under the same organization. In this case, we would like to add a new device because I want to show you how to configure this connection. So there is a plus button in the right top, and there is a pop-up window where we need to put information about our new gateway. So let me add IMG4312, the demo. Then we need to put a mandatory field, which is a unique serial number. We can, of course, read the serial number from the device label. I have it prepared before, so I will copy and paste it here. And that's actually it. Only these two fields are mandatory. So when we will click confirm button, the gateway will be already successfully added, but we have some other optional fields which we can fill in to have more information about our device. Like, for example, MAC address of the device. In this field, you have to remember that the MAC format must match exact format. I will also copy and paste it here from my device. You can select VPN connection mode. You can check the WAN connection type. So I know that my gateway later will be used wireless Wi-Fi client mode, so I will choose this one. You can put GPS coordinates to visualize your device location in a map interface. So let me do this right now. I will use location of my city in Poland. I have also prepared them before, so I will just copy and paste them here in the window. You can add a description. For example, this is my demo gateway. Country will be Poland, city Gdańsk, and you can add some remarks for another users of the system, like for example, do not remove or anything you need in this field. I will click confirm button now. And let's wait a second until the device is added. As you can see, adding is successfully completed. And there is a very useful, helpful pop-up window which shows the unique Connect Gateway ID. We can copy this gateway ID right now, because later we'll need it in our gateway configuration. If you need to access this gateway ID again, there is an action button and modify feature where you can copy and paste it from here. Our gateway is already added, so it also should be already available on the map interface. So there is a in the right top part of the interface, there is a map button where you can open it and check devices locations that are added to your list. So we just created this device, which is located in Poland. And you can see its status. Now it's offline. It's offline because now we need to add the configuration of our IMG4312D gateway. I have this gateway connected now with a LAN cable to my notebook, so I will simply use its web interface address, which is 192.168.10.1, and I will log in with factory credentials, which is admin, and I'm accessing the gateway configuration page. As you can see, the gateway is already online. I made this configuration before, so the one configuration is already added. I'm currently using Wi-Fi for connectivity, but there is no problem for the user to use a cellular modem, so LTE connection or LAN connection with Ethernet cable. So if we already have our Connect Gateway ID, the configuration of the gateway is only related to enabling the feature of MagiConnect in this menu and pasting the unique gateway ID. I will apply these settings, and we need to wait for several seconds until the connection is established. Okay, so our register status is already online. So if we go back to our MagiConnect dashboard, you can see that the gateway status is also online here. So this is the first step. The next step is opening our ConnectClient tool on the machine which wants to access this gateway remotely. So if you still don't have ConnectClient on your PC, there is a ConnectClient button also in the right top. From here you can download the Windows installer and follow the standard procedure for installing the software. I have already ConnectClient on my machine. I will simply open it, and the configuration of ConnectClient is related to copying the ConnectClient ID, which is also very simple, and pasting this ID here in that window. So as you can see, my ConnectClient is already online, it's registered, and the status in the dashboard is also online. So if both of them, the gateway and the ConnectClient, is online, we can proceed with connecting them. So I will use action button and connect action to establish the VPN tunnel between my PC and the gateway which you just added to the system. As this is VPN connection, it takes a while. It can take usually between 1 to 2 minutes. So we just have to patiently wait at the moment. Okay, we can see the VPN status is connecting, and VPN status is connected. So basically now if we'll go to our Network and Sharing Center and check our adapters in the Windows operating system, you will see that there is new TAP adapter added in Windows. Here in our dashboard, I will quickly refresh the interface. Just need to wait a few more seconds until the status is also refreshed in the dashboard. We'll be able to see that our gateway is already connected. Yes. So if the gateway is connected, you will be able to see the new status icon here in this field. And there is also a new list of active connections added. And now, because our gateway is already connected remotely, I can disconnect my LAN connection with the gateway. So I'll open the Network and Sharing Center again. You can see that I have two connections now. I will simply disconnect the Ethernet cable. You can see that there is no physical connection right now with the gateway. I can close it. But if I will open the command prompt from Windows, I will try to ping it now. 168.10.1, which is the IP address. And you can see there is response from the gateway. It means that even if the gateway is disconnected physically from my notebook, I can still access it. So if I will click its IP address, the system will help us to open its web interface. And I will simply log into it again. So it means we can configure this gateway remotely right now without physical connection. I will go back to the console. Here you can also add some other devices which later are connected to the gateway, like for example PLCs, IP cams, HMI devices, and it can help you to control the device from here. Now to show you the real value of this system, I will simply disconnect my gateway. And there is another gateway which is visible as online now in my dashboard. This gateway is actually located in India, in Pune city, in our Indian office. It means that I can access this gateway here from Poland. And this gateway is connected to a Siemens PLC. So what I want to show you now is that the real use case, I will try to access Siemens PLC remotely from Poland. So let me open connection with the gateway, which is already configured in India. We again need to wait for 1 or 2 minutes until the connection is established. Okay, and it seems our system is already connected remotely to the gateway. Let's just wait a second until our interface is also refreshed here in the cloud. Okay, good. We are connected, and in active connection list, you can see the gateway and the Siemens S7 1200 version of the PLC. So now, because I have the Siemens software, I will open it from my notebook. I will open the existing project with this PLC. Good. And now I can choose the PLC from the list and click Go Online button, and we will see if we can establish remote VPN tunnel between my PC in Poland and the PLC in India. Perfect. As you can see, the status is green. In the right bottom corner, you can see that we are connected to the PLC. So now we can basically control the PLC, change its configuration, check its status, and many more. So this is a good proof of our use case where MagiConnect can be used. Okay, I will close it now. Close the software from Siemens. Disconnect the gateway, and we'll move to another part of our presentation today, the webinar, which is MagiCollect. Okay. So now I'm moving to MagiCollect feature. So as the presentation showed us today, MagiCollect is the solution for collecting the data remotely from our gateways. So in this case, the website is magicollect.ssas.oring.cloud. Here you can also find information about this system and its features and applicable models. From here, you can also run the dashboard of MagiCollect. I will log in with my credentials as I did it previously with MagiConnect. As I'm already logged in, I can add a new device. So let's do it right now. For demo purposes, besides the gateway, on my desk I also have a temperature and humidity sensor, which is using serial connection and Modbus RTU. So we are using Modbus RTU to pull the data from the sensor and upload this data of temperature and humidity to the cloud platform. So maybe I will call it as a sensor 1. I don't have its serial number right now, so I will simply put something like this. I will not use GPS coordinates now, but I will choose the think model from the list. So our device is IMG4312D, D4G. And I will add this device. Action is successfully finished. You can see the sensor 1 on our list. Let me open its configuration. Because we have added IMG 4312D model, which supports one digital input, one digital output, these fields are already added automatically with device configuration, so we don't need to make any additional configuration. But as the sensor is different, it's another device, we need to establish Modbus RTU connection between the sensor and our gateway. So we can add the configuration here in the gateway section. So here is the Modbus RTU port configuration, and now we want to add configuration for the Modbus fields. So I know the humidity value will be pulled with Modbus RTU master with net ID 1. The start address is 0, and the number of data will be 1. We'll be reading holding register and signed value, so integer. We can name it humidity. Percentage as a unit, and add another configuration. In this case, the start address will be 1, number of data 1. We'll be reading holding register, and the name will be temperature in Celsius degrees. And that's actually it. These two fields are needed to get the information from the sensor, so I will apply these settings. And now we still don't have any data in the dashboard. It's null because we still need to add the configuration to our gateway. So if we'll go back to the gateway information, our device information includes a unique identity and secret. We just simply copy and paste these values to to our device. So I will use the IP address of the device, log in again, go to our MagiCollect menu, enable it, copy the identity, copy the secret value, and apply the setting. Again, we need to wait for several seconds until the connection is established. And it's already connected, as you can see. So if we'll go back to our dashboard and refresh it, you can see the sensor 1 is already green, so online. In this case, we should be already able to see our data in several seconds. In the meantime, until the data is loaded, I will also show you the digital input, digital output configuration. So there is a system tools, DIDO menu here in the gateway. I already have another voltage source prepared here to close the circuit of the digital input. So if I will close the circuit here, you would be able to see that the status of DI is changed. We can also control the digital output status from the menu of the web interface. However, we want to control it remotely. So let's do it right now from the cloud platform. Okay, you were able to see that I could already control the status. I can already visualize the status, so I will close the circuit again. And the DI is also, the change of the status is visible here in the dashboard. And the same we can do with the digital output. We can send a command from the cloud, from the cloud dashboard to the device. Action is successful. Let's go back to our interface, and you can see that the digital output status is also changed here in the gateway. So it means that we can remotely control some devices which are using digital signals for example, turning on or turning off. I still can't see the information from the sensor yet, so let me double check its wires, if everything is added correctly. For troubleshooting, we can always go to our MagiConnect, MagiCollect menu, and open information window. Okay, I think the data was not sent, the configuration was not sent to gateway yet, so let me double check it. I will delete the configuration and add it one more time. So please allow me a few more minutes to configure it again. Okay, information is applied. So just wait a second for reaction. Yes. So you can see already the humidity value and the temperature value, and we can open a chart which will show us historical trend in real time. So this is basically how the configuration of both MagiCollect and MagiConnect features recently released by ORing for work from home solutions look like. If you have any questions, we can have a questions and answers slot right now. So if you would like to ask any questions, please raise your hand. We'll unmute you and try to give you the answers. Okay, I think I don't see any questions. The video recording, the webinar recording will be available later for all the attendees. So hopefully you enjoyed the presentation today. Thank you so much for joining us and having the time with us. I hope you find the solution interesting. So in case of any questions, you can always reach ORing team with your inquiries for the solution, and hopefully we'll see the real use case of our products really soon in the field. Thank you so much.